Quality assurance testing is a form of testing that closely mirrors user behavior. Sometimes it is manual, and sometimes it's automated. Automated QA tests are scripts that validate correct data representation as the application mechanically runs through high-level workflows, like a login page. Manual QA testers act out use cases of an application to see if there are any bugs that were missed during automated test cases. Manual QA testing is often necessary for complex applications where it is not possible to enumerate all potential workflows within a script. Different companies have different workflows for QA testing. There are a variety of ticketing systems, testing frameworks, and team chat applications that play a role in a tester's daily life. QASymphony is a platform for testing tools that integrates with other popular technologies to centralize a QA testing workflow. Jonathan Alexander is the CTO at QASymphony. He's also the author of Coder Metrics, Analytics for Improving Software Teams. He joins the show to discuss the past and the present of QA and his strategies for managing the team that is building QASymphony. Thanks to Kevin Wolf for the intro for this show. Developers love Docker containers because they give applications portability and consistency all the way from your laptop to production. But things can get complicated fast when the time comes to deploy, manage, scale, and secure containerized apps in the cloud. Amazon EC2 Container Service from Amazon Web Services makes it easy to run Docker apps in production. With Amazon EC2 Container Service, installing, updating, operating, and scaling your infrastructure happens automatically. Using simple API calls, you can launch and stop Docker-enabled applications, query the state of your cluster, and natively integrate with powerful AWS services like security groups, elastic load balancing, EBS volumes, and more. Best of all, you only pay for the AWS compute and storage resources you use. With Amazon EC2 Container Service, you can focus on building apps, not spending time deploying, scaling, and managing your container infrastructure. It's time to get back to what you do best. Learn more about Amazon EC2 Container Service at ecs.aws today. That's the letters ecs.aws. Jonathan Alexander is the CTO at QASymphony. Jonathan, welcome to Software Engineering Daily.
Thank you, Jeff. Glad to be here.
So today we're talking about QA testing in 2017. This is an important topic. It's been an important topic in software for a long time, and it's an evolving field. So for people who are unfamiliar with this topic, let's level set. What is QA testing?
QA testing is the process to ensure quality of the software that we're building and delivering to our customers. And there are, as you say, a number of techniques that people use to ensure quality, and it may involve humans testing the software, it may involve machines testing, it involves a lot of analysis of results and feedback, but that's what QA is about.
Right, so there's these different aspects of software testing. There's integration testing, there's unit testing. I think the way that I always hear it explained is unit testing is you're testing your new feature that you're developing in isolation. You're writing unit tests to test it, a battery of basic functionality. And then the integration tests are the tests that trial the points where your software integrates the feature that you're working on as a developer in isolation. It tests up against the broader piece of software. Assuming you agree with those definitions, how does QA testing contrast or compare to the unit test and the integration testing process?
Well, yeah, so people use those two terms, and certainly unit testing and integration testing are two separate things, and in common practice now people will do both. Sometimes people talk about another, even third layer, which would be acceptance testing or user acceptance testing. Sometimes people just describe the UI testing as that final third phase. And so integration might be at the API level and the integration between different working server systems, and the third level would be the user testing or the UI functionality testing. So it's very common practice today that the developers implement unit testing themselves. And as you say, that's to test the discrete parts of our software and the programs that we're writing. And that might be, for example, that you're developing a code module, and on a certain kind of input, the module performs a function and provides a certain kind of output, and you might have expected results and expected failures, and you can write unit tests that every time you change the software, you can run those unit tests, and they'll confirm that that basic unit functionality is working. Mm-hmm. But the QA process, and where we get into what people traditionally refer to as QA and work that a QA team might do, would typically get involved at that integration testing level, and at the third level, which we can call user testing, user acceptance testing, or functional testing.
Mm-hmm. You know, I've done a lot of shows about this DevOps area, and one of the things that I think gets less attention in DevOps and continuous delivery and these topics that are a little sexier to talk about is if you don't have tests in place, it's really hard to do continuous anything, because the whole idea of continuous whatever is developer pushes their code to GitHub or whatever source repository you have, automated tests run against that new code, and some other tests run against that code, maybe some human testing, and then you click a button and it pushes to production. And if you don't have testing in that loop, you can't actually get continuous anything. Would you say that's accurate?
I would say that you need to have testing somewhere in the cycle, and, well, assuming that you care about quality. What some organizations are doing is their testing takes place in production. So there is a certain amount of automated testing that they might plug into the cycle as you describe. But some organizations are actually okay with the idea that they would be do continuous release, and that the final parts of testing might actually be in production. And they might have capabilities that they've built that would make that controllable and acceptable to them. So, for example, there are organizations that might release something into production, but then expose the new release to a very small sliver of users to start. And they might have extensive monitoring over the performance and the results and issues getting reported by those customers. And if it's successful, then they might increase the traffic flow to the new code and reduce the traffic flow off the old code gradually until they hit 100% move over. So one way you can do continuous integration and deployment and include testing in the process is to use production as part of your test environment. But it typically would involve those kinds of controls, like the ability to control traffic in production and the ability to really monitor the results of what happens in production. That said, that approach is not for most people. Many organizations and a lot of the software that we write, that isn't something that the users might tolerate. It might not be something that the organization thinks is acceptable as a QA process. And in that case, what you said is 100% true, that then if we're going to do continuous delivery, we have to automate all levels of testing, unit integration and acceptance, and bake that into the process. And we'll either automate it or include our human testing as part of that CD process.
And I think it totally depends on the type of the product and the size of the team. For example, I'm working on a software company myself that's essentially a photo sharing consumer application, and if something breaks, nobody's going to lose their life. But if you're working on healthcare software, for example, or like an EMR, electronic medical record system, you probably want a little bit more of a rigorous testing process. So like in my photo sharing consumer app where nobody's going to get hurt if something breaks, I have, our process is we've got a QA environment, we've got production, and then whenever somebody wants to do a new release, they make a review app, and then the review app just gets spun up. People can do some manual testing on it because we've got just not very much functionality across the entire app. So it's not hard to systematically go through kind of all the user workflows. And then if that all goes according to plan, we push it to QA. We can do a little more manual testing in QA, and that's sort of like supposed to be the stable environment. And then if everything goes well there for a while, we can promote that to prod. And that works fine for an app with kind of more narrow functionality where people are not depending on this day to day for something life-threatening. But when you get to a point where there is so much surface area to an app, you probably need more control, you need more organization, or, you work at QASymphony, and QASymphony is essentially software that helps people manage their QA process. So even if, let's say I was to try to scale that manual testing system, or even if I wanted to just introduce a little bit of automated testing along with the manual testing, my understanding is that QASymphony is a platform that will help me do that. It will help me scale whatever my quality assurance testing process is. So maybe you could describe a little bit how that works and what you have noticed about the QA testing process that you're able to improve with a software platform.
Sure. Yeah, the process you described is a standard process that you find a lot of organizations at different scale where they'll have different gates and the software moves kind of from one gate to another stage until it's released. And as you say, different organizations have different requirements and therefore different tolerance and, on how quickly we'll move things from one stage to the next and through the gates. And sometimes the requirements aren't just internally imposed, sometimes they're externally imposed, that because you're providing a certain kind of service like financial services support or healthcare, you may be subject to regulatory compliance and you have to make sure you're meeting those things. So however fast we're willing and able to create software and test software and release software, everybody wants to go faster. Everybody wants to be more efficient. And so what we've seen and what, we try to enable and pretty much the problem that we and many others are working every day to solve and make better is how do you increase the efficiency of that development, test, fix, retest, release? How do you increase the efficiency and tighten that loop up? And pretty much what I'd say is the most important thing that we've discovered and that we work with customers on, and it's a concept that people could apply in a lot of different ways, is that the testing just needs to be really well integrated with the tools that the development team is using, and if we're doing DevOps, that the DevOps team is using for managing the process. So a lot of organizations we work with, for example, the majority are today doing Agile, and they do, Agile planning, Agile development, and they use a tool usually to, manage that Agile process. So a lot of people use Jira, people use version 1, Rally. So one of the keys is, if you're going to tighten that loop, is to make sure that your testing effort, whether it's automated or manual or a mix of automated and manual, is really tightly integrated with that process, which means tightly integrated with that tool. So, making sure it's really tightly integrated with Jira or version 1 or Rally, because that increases it decreases the time lost between the development effort and the testing effort. It increases the feedback if it's directly integrated, so that if there's something that still needs to be worked on, you get that feedback really accurately and really fast. And it also, goes to if we need to have confidence that we've tested everything and that we've covered everything, then we're able to do that. The same thing applies in the CD space. So if you're doing DevOps and you're doing CD, then what are the tools you're using for that? So a lot of people are using their CI system. So they might be using Jenkins or Bitbucket or or Circle CI or something like that to manage their CI/CD process, or they might be using a CD system like a Spinnaker or GoCD. So in that case, what you'd really like to do is, again, really tightly integrate the test process and the test feedback directly into the CI/CD system, so that, again, if it's automated or manual, that you're directly tied in, and that is like the workflow you described, where something developer does a check-in, and now I have a build, and the build would go to staging, and now I need to do some testing, and now we're talking integration testing or user testing, and then if it fails, I need to get the feedback on what exactly failed, what piece of work, what code check-in, was involved, so I can go back and fix it as quick as possible. If it succeeded, then I can kick off the push to production. Again, the key thing is to make sure that your QA is tightly tied in with that process, which means tightly integrated with those tools. And so, for example, at QASymphony, that's kind of one of the key things we focus on, is the integration of the QA process management, and the tools that the QA team needs are able to be closely tied together with those tools.
Look for a job more efficiently with Indeed Prime. Indeed Prime flips the job search model and lets you find a job more efficiently even while you're busy with other engineering work or coding your side project. You simply upload your resume, and in one click, you get immediate exposure to companies like Facebook, Uber, and Dropbox. The employers that are interested will reach out to you within 1 week with salary, position, and equity up front. Don't let applying for jobs become a full-time job itself. With Indeed Prime, the jobs come to you. The average software developer gets 5 employer contacts and an average salary offer of $125,000 through Indeed Prime. It's 100% free for candidates. There are no strings attached. Sign up now at Indeed.com/SEDaily. Thank you to Indeed Prime for being a repeat sponsor of Software Engineering Daily. And if you want to support the show while looking for a new job, go to Indeed.com/SEDaily. Right. So my most intimate experience with software testing was one of my first internships. I had an internship at a company called Spiceworks in Austin. And Spiceworks makes a social media, basically a social network for IT people. And my job at that company was to write unit tests around, well, I guess it was unit and integration tests around the web platform. So I would just write scripts to test this Ruby on Rails application, and these would be, if I remember correctly, these were run during the continuous integration process, and then it would go into a QA environment, and the person who sat across from me was a QA tester, and they would operate mostly with Jira. So there would be Jira tickets here. There's this. Well, actually, no, they would be the ones filing the Jira tickets oftentimes, or looking at pre-existing Jira tickets and that they had filed and saying, okay, has this bug been fixed? Okay, yes, they test it manually and they verify, okay, this bug has been fixed. Oftentimes they were testing things that were subtle functionality or features that were so incredibly hard to automate because they were just like really complex or subtle or covered a wide surface area, or there might be race conditions that are hard to put in programmatically into unit tests or integration tests. So, but anyway, they were operating mainly out of Jira tickets. They were operating out of a ticketing system. They were a QA person, and I don't think it would have occurred to them, it certainly wouldn't have occurred to me, that, oh, actually, this type of person could use their own platform. Not necessarily Jira. I mean, Jira is great. You want to use Jira or some other ticketing system, but you might also want a full-fledged QA platform because this is enough of a complex job, and you can save a lot of time if you have some other software platform. So kind of explain the difference between a QA person who does not have a QA testing platform and how their job might change, how their interaction with other people on the team might change once they have a workflow that has the additional usefulness of a QA platform.
Yeah, in the QA space, there's a variety of tools and products and solutions that the QA team might use and typically would reach for some of them. And part of the choice of the tools depends on, as you pointed out, what type of testing we're looking for the QA team to do and that they need to do, and the type of system that's under test. So, for example, if we're doing manual testing, then one of the things that we may need and we may have is over time, we may build a library of test cases. And those test cases, depending on the breadth of our product, could get, the test case library could get very large. We deal with many customers in a wide variety of industries, and I know, many of them have libraries of hundreds of thousands of tests for a single application, and they're not going to run those are manual tests. They're not going to run those 100,000 tests every time, and it depends on what functional area of the product they're working on, which tests they're going to reach for and run. So the tool and the help that QA teams need in that case is the management of that library. A lot of times the tests that we have in our library we need to parameterize. So we write a test and we say I have to input an address, and I need to try inputting a good address and a bad address, and I therefore want to parameterize my test, and I want to keep data sets of good addresses and bad addresses and just be able to pull them in. And then when I run those tests, those manual tests, I want to track what am I doing when I run that test, and which step did I execute every step? Did it pass or fail? Because I may have to run these tests multiple times on any release. If there's a bug, I have to enter a bug. So in the, if that's a problem that people are trying to deal with, they can reach for a variety of tools, and the simplest case is I can just write tests and keep it in a doc, or I can write them and put them in a spreadsheet. But, then if I really have a large library and I want to organize it and I want to run those tests over and over again, and I want to be able to associate my tests with specific tickets and go back to, that integration with Jira or the integration with one of the other systems, that's where QA teams start looking for something more robust that will let them manage a test case library, gives them capabilities like parameterizing the tests, gives them the ability to track when they run it in a IE browser versus a Chrome browser, gives them the ability to easily create bugs that go into the bug tracking system, and gives them a lot of reporting on what tests are planned to run and how are we doing on that plan, and how much longer are we going to need to complete the test plan. That's where the more robust system comes in and where people need that. And that just talks, so what I was talking about right there is manual testing. If you're doing other kinds of testing, if you're doing automated testing, then people have a different set of needs, and there are different tools that people use. Some of the tools that people look for in automated testing, well, first of all, of course, there's the system that runs the automated tests themselves. Like there's a lot of commercial products for running automated testing, writing automated test scripts, and there's a lot of great open source. And a lot of companies today just use the open source, Selenium, Appium, Protractor, things like that. But even in that case, people, for example, would still like the ability to trace specific tests back to specific Jira tickets. And they would like reporting and historical analysis and reporting on, well, if there were failures, which specific Jira ticket or which specific code check-in did that tie to? So they might be looking for reporting, and there are, tools you can get for that. Another area related to automation that we see a lot of companies now adopting as a best practice is using some of these BDD, behavior-driven development, or what some people call ATDD, which is acceptance test-driven development, where people use these frameworks. Cucumber is very popular, and there's a BDD language that works with Cucumber called Gherkin that many people are familiar with. ThoughtWorks has put out a framework called Gauge that works with Selenium. There's a framework called the Robot Framework, and a new one called Karate that works for API testing. And what these systems let you do is essentially write your requirements in an English-like language that becomes the framework for your automated test, and it in the end becomes documentation on the requirement that is associated with the automated test. And then when you run your automated test and something fails, you can go back. Now you've immediately associated it to the actual business requirement that test was executing. So for integration testing and user acceptance testing, BDD is a kind of a best practice that a lot of organizations are looking to. So that's another area where tools come in.
Define that term a little bit more, BDD, because I've heard that before, but I don't know quite what behavior-driven development is.
Yeah, so the idea is that you would define the behavior that you are seeking to implement first. And by behavior, we mean the kind of the business requirement or the user functionality that you're trying to implement. So if we just took the most simple case of like a login screen and if we needed to implement a login screen for our new application, in BDD, we would define the behavior of the login screen, and potentially we would do it before we even implement the code, and that would lead us to where, if when people talk about test-driven development, BDD is one way you could do test-driven development. When you write the behavior, what you do is you define in a formal language. It's English-like, but it's structured. You would define what you want, what the functionality needs to do. So in the case of the login screen, we might write something like, when the user opens the login page, then they enter their username, then they enter their password, then they click on the login button, and then we expect the homepage of the application to load. So that definition would be what we would call the behavior, the expected behavior. And these different systems that I described, Gherkin, SpecFlow is another one, Robot, Gauge I mentioned, they all have a specific syntax for writing out those behaviors that is structured. And once we've written out that behavior, then we can actually automate the test. We can develop an automated test that executes each part of that. So in that case, we've described not only what we want our login page to do, but we've basically described the structure of an automated test that would test the login page. And so some people call these assets, these behaviors that are written in these formal languages, some people refer to it as executable documentation, because it's actually kind of like documentation in what the system's supposed to do, but we can write the automated test for it and we can execute it. So the benefit is that, again, if we want to ensure that we're testing everything we're implementing, one of the benefits is if we use BDD, we can formally write down everything we are implementing that we need to test, and then we can actually make sure we've written the automated test for each one of those things. So it's a great way. So a lot of, and actually what we're seeing is a lot of, I've been surprised over the last year to see the number of large organizations that are adopting BDD. But part of the reason is that a lot of these organizations, they do want to push forward on a lot more automated testing, but they still want to ensure that they're getting the coverage and that they can check what they're covering when they're writing the automated tests. Another benefit of it is that one of the problems that you can have when you're implementing a lot of automated tests is that you can lose track of what all the automated tests cover. If you write 100,000 automated tests, and all you have is the code in your source repository, it can, you can lose track of what each one of those tests do. Over time, you don't know, well, do I really need to keep running all these tests? And if if it takes too long to run the whole library, it can get hard to decide which ones do you need to run. So if you use the BDD approach, it's also a way that you've essentially ensured that you're documenting what each automated test does. So it's another great advantage of it.
Your enterprise wants to adopt containers, but you aren't sure how. CoreOS will help you along your journey to a containerized architecture. CoreOS are the container experts trusted by Salesforce, eBay, Ticketmaster, and other world-class organizations. Go to softwareengineeringdaily.com/CoreOS to find our top 5 episodes about containers and Kubernetes, as well as a white paper about migrating an enterprise to Kubernetes with CoreOS. They've hosted, attended, and spoken at many shows about containers and Kubernetes because those technologies are the future of the web. That's why CoreOS built Tectonic, an enterprise-ready Kubernetes platform. At softwareengineeringdaily.com/CoreOS, you can learn about how containers can make your organization run more efficiently. Thanks to CoreOS for being a sponsor of Software Engineering Daily. I want to transition into talking about how engineering at QASymphony itself works, because you're the CTO, the company. Can you describe the software stack that QASymphony is built with and what the development process is like for the company, and how that, those the opinions that you have about software development, how those translate into how you build features for the QA testing platform that you're building?
Sure. Well, we have about QASymphony, we have about 50 folks in our development organization at this time. We are distributed. We have teams in multiple locations. We have a team that works in Vietnam and another team in Atlanta in the United States. So we have a set of products that cover some of the areas I've been talking about. So we provide a system for managing manual test cases and test case library management. We have a system for products for BDD, which I was just describing. We have tools for exploratory testing. And we have a reporting and analytics package. So we have a number of products, and we have a few stacks. Our test case library management application is a Java stack, Java backend, Angular front end, and we typically rely on open source databases. So we use Postgres and MongoDB, both. Some of our other products, like our BDD product, is a Node.js stack. So it's Node.js on the server and Angular on the front end. And so those are the two main stacks that we use across our applications. We actually try to make sure we utilize all of our products. So we force ourselves to use a variety of testing methodologies. Our developers write unit tests, and our developers also write other integration and user or functional tests as well. We do force ourselves to use a few different systems for that so that we're testing how we work, for example, with Selenium and Protractor, and we use Postman quite a bit, and we use JMeter for performance testing. We do a mix, therefore, we also do manual testing on one of our software is delivered in the cloud. We run, our software can be used in the cloud on demand, but our software can also be downloaded and installed and run on companies' own servers. And so when we release software, we not only have to push to the cloud, but we have to push to versions that can get installed on Windows or Linux. And, so we have to test the installers, for example, and that's a manual to run an upgrade, and test and upgrade is a manual process. So we have manual test cases. And so we do a mix of manual, we do a mix of different types of automation and integrated automation. And we also use our exploratory tools. So we do exploratory testing on some of our products. So it's a variety. We have different release cadences for different products. We use CI system, and we have some products that are very close to continuous delivery into the cloud, which we do release multiple times a day. We have some products that are on a slower cadence where we might release every few weeks.
It seems like the different products that you have across the the company's product suite are fairly disconnected, and like maybe the integration points are just kind of like RESTful integrations, and maybe that cuts down on the pain of continuous delivery. Is that accurate?
Yeah, I think if you're saying how do our products integrate with the CI system, is that what you're asking, or the CD system?
Yeah, basically, and integrate with each other. Like if you because you have a product suite, right? And your different products integrate with each other.
That's right. Yeah. So yes, that's essentially correct. Is that our products have a certain level of kind of API and UI integration. So if you're using our product suite, it's kind of like using Google G Suite. Like you have different applications, like I can go to Word or Excel or PowerPoint. In our application, you can go to the BDD tool or the manual tool or the exploratory tool. The key points of integration are around how we integrate with the Agile system like Jira or the CI system, or also how we do reporting. So all of our products integrate with Jira, for example. And so if you have a ticket in Jira, you can now do planning on which testing you want to do for that Jira ticket, whether you're going to do manual, BDD, or exploratory, or just pure automation. You can use the QASymphony product to plan or associate which tests go with that Jira ticket. And then you can get reporting on the results, or you can see those results right inside Jira. So it's a suite. It's integrated, as you say, with webhooks for integration with Jira, integration with CI, integration with the version control system, by the way, as well. So events in those systems can automatically push activity to the test system so that the test team, make sure to do the proper planning and the proper association of those items. But then again, the results can go right back into the CI system or the Jira system. So, for example, one cool thing we do is that if you have manual testing and the manual tester runs a test and the test fails, that test result can actually go back to the CI system and fail the build. So if you think about it, people do that all the time with automated testing. You kick off the build, then you run the automated test. One of the tests failed, the build fails. Well, what if I have manual testing? And if the manual test, maybe I should not say the build is passed until the manual test is complete. And then if the manual test fails, why not just fail the build? So again, that's kind of the integration points that we support. And yeah, it goes back to what I was saying earlier. I think that's whether you use QASymphony products or not, thinking about how the QA gets integrated into the process really means thinking about how QA gets integrated into these tools that we use.
And what about Slack or HipChat? Because the Jira system is the kind of the ticketing system. That was kind of the unified communication platform of 3 or 4 years ago. Companies that are getting started today are maybe interacting a little bit more, and they're interacting over Slack or HipChat or maybe Facebook Work, Microsoft Teams, whatever it is. The pace is faster, and I think the integrations are maybe in a sense similar, because you probably have just this event log of things that are happening in your QA platform like QASymphony, and those things are getting published to some sort of big pub subsystem, and the integration points are subscribing to whatever the publishing channel is. Could you talk about, I guess, I know we're nearing the end of our time, but talk maybe a bit about how you see Slack or these other real-time communication systems fitting in and how those integrations work if it's some sort of evented system.
Yep. So we are heavy users of Slack here, and also we were one of the first providers of a plugin to Atlassian's HipChat. So we were one of the first companies when they opened up HipChat for third-party plugins to deliver there. And as you and I've talked about, big part of getting more continuous is tightening the loops of communication and speeding up the process. And so the chat or communications channel is a key part you could use for that. The QA system really does become kind of this key pub sub kind of hub of information about if you have a QA platform or a QA hub, that's, as you run tests, well, first of all, as you need to run tests, you want to know that as soon as possible, and that's where the tie-in to the build system comes. As you pass or failed tests, you want to let various systems know. You may want to let people know. And so, for example, in QASymphony, we have a capability where you can write event rules and customize what happens on different events and what goes out to what channels. And so, for example, if a test fails, whether it's manual or automated, you might want to Slack notify the individual developer whose ticket failed, for example, that, hey, your ticket failed. You might reopen the ticket in Jira, but you might send a Slack notification too. If everything passed and you're pushing to production, you might want to Slack notify a group that, hey, all the tests passed. And so we're triggering the next event. So we have a capability that we've implemented, like a lot of other systems, where you can write rules and specify on what events you want to do a Slack notification or a HipChat notification, or change a ticket status in Jira, or open a new ticket in Jira, and we let people customize those. And we also think there's another, the reverse is that like what we've done with HipChat is basically implement a bot so that if you're in HipChat or you're in Slack, if you want to just inquire, how's testing going? How are we doing? What's the current status on the test run? We've implemented bots where just in HipChat, you can basically, request update on the current status of the test plan. And so, basically you can speak to the QA system through the communications channel and say, give me an update on the latest test run. And it'll show you back right there the results, the current, percent run, percent passed, percent failed, time estimated to complete. So again, just looking for ways to speed up the communications process and help people work more efficiently.
Cool. So I know we're wrapping up, and you've worked as a CTO at a few different companies for the past 7 years. So I'd love to just I don't know if you have a few pointers about the job of being a CTO. I don't know. What are the most succinct lessons that you've learned in your time as a CTO? Wow,
that's a great question. And I'll try to think quickly about what I'd say about that. I think one key lesson I've learned is that you need to not shy away from some of the hard problems, and taking on some of the hard problems that you see, taking them on early and really making sure the team is focused and that you wrestle with those hard problems early pays off. The investment, can be really critical to the growth. And so, as you said, I've now done this a few times, and I think we all know when we go build software, we tend to learn after we've shipped the software that there's something if we had it to do over again, we might do different and we might do better. Also, there's unanticipated situations that we face after we roll out software, and there's just new learnings that come from engaging with customers. So, I think that a key aspect of the CTO role is to help identify what are some of the technical issues or challenges that lay ahead for the technology and the product that the company delivers, and to help identify those and help the business understand why those are important to solve. And then, as I said, solving those things early will pay off in efficiency later. And so as I've progressed doing this, I've gotten more and more proactive about making sure we solve those technical, that we deal with what, some people call technical debt, that you deal with that earlier rather than later, and that you have a really strong policy that you're going to pay down that technical debt, and helping the business understand that and helping the team identify how to do that.
Absolutely. Well, that's a great lesson to close off with. I have found the same to be true in running a podcast. So, Jonathan, thank you for coming on Software Engineering Daily. It's been great talking to you.
Thank you, Jeff.
Simplify continuous delivery with GoCD, the on-premise, open-source, continuous delivery tool by ThoughtWorks. With GoCD, you can easily model complex deployment workflows using pipelines and visualize them end-to-end with the value stream map. You get complete visibility into and control over your company's deployments. At gocd.org/sedaily, find out how to bring continuous delivery to your teams. Say goodbye to deployment panic and hello to consistent, predictable deliveries. Visit gocd.org/sedaily to learn more about GoCD. Commercial support and enterprise add-ons, including disaster recovery, are available. Thanks to GoCD for being a continued sponsor of Software Engineering Daily.
Wow!